Hello everyone, thank you for joining us today. I am G. Sunita along with T. Shravanti, CH Parmeshwari and M. Shruti. We have worked on IIT based home automation system during our internship at MTech and we have presenting our PowerPoint presentation today. Our goal was to explore the fascinating and Internet of Things we make everyday living easier and home more efficient than during this internship. We learn about internship sensor integration and cloud-based control platforms. We are excited to share how to design and implemented this project step-by-step combination technology and creating a build to connected home environment to build. Not let me explain what this internship and primary aims to build understanding of the internet of things embedded things. Learn revolve is the role of the practice through weekly assignments review on the internship overview primarily aims to build understanding of the internet of things IoT and embedded system. Learn the relevance and role of IoT in everyday applications. Evaluate participants through weekly assignments. Reinforce learning using simulation based projects. Offer mentorship to beginners entering the IoT domain. Here we can see concepts converged in this internship. C programming topics including keywords, data types, operands, loops, arrays, functions, pointers, and memory uses. C programming focus on object oriented programming concepts, IoT based definitions, architectures, and partial users, embedded systems. Key peripherals such as Arduino Uno, LEDs, CLCD sensors, LDR, LM35 and PWM concepts. Here we can see C programming. C is a widely respected general purpose programming language designed in the early 1970s by Dennis Ritchie at Bell Laboratories. Now, for this portability, C is both powerful and efficient, forming the backbone of operating systems, application software, and embedded system. Its syntax encourages structured programming embedded system. It's enabling developers to organize code into well-defined functions, manage memory directly, and implement complex logic using variables, constants, and a variety of data types such as integrands, variables, constants, and a variety of data types such as integers, floating point numbers, arrays, pointers, and user defined structures. C supports procedural programming, recursion, and static type checking, which helps programmers write clear, manageable programs while maintaining high performance. The language's concise and readable syntax makes it accessible to learners, as it is flexible enough for explainer developers to create efficient software for device platforms. About C++, it is an object oriented language supporting key concepts like classes, objects, encapsulation, inheritance, polymorphism, and abstraction. C++ allows both high level and low level programming, making it usable for system software development and large scale applications projects. The language is statically typed, meaning variable types are set at compile time for better performance and error detection. C++ programs are machine independent and portable code can run on any platform with the appropriate compiler. It is combined and provides fast execution, making it perfectible for performance a critical application. C++ supports features of both procedural and genetic programming in addition to its object oriented programs. Here we can observe introduction on embedded systems, key components including smart lights, Starts, logs, cameras, applications, motion sensors, actuators for controlling physical like blinds or wall use. Automation enables scheduled routines or trigger based actions. For example, lights turning on when motion is detected or temperature adjusting based on presenting and time of day. Security is enabled with smart locks, alarms, windows, door sensors, surveillance cameras, and instant notifications of as usual activity. Voice assistants such as Amazon Alexa, Google Assistants can be integrated for hands-free operation of devices or custom automation. Smart home systems save energy, increase convenience, enhance comfort, and improve the safety to the home environment. Internet of Things. Here we can observe the Internet of Things. It is a network of physical objects such as devices, applications, or sensors that are embedded with technology, allowing them to connect and exchange data over the Internet. IoT systems consists of three core elements: smart devices, sensors, or actuators. Calculators connectively infrastructure and data processing technologies on the internet. IoT system consists of three core elements: smart devices, sensor, actuators. Connectively infrastructure and data processing mechanism could or edge analytics. Smart devices gather environment data and send it through gateways or network protocols like Wi-Fi, Bluetooth, 5G, or cellular data that can be worked on, enabling interaction and remote management. The data collector is then analyzed often with AI or machine learning algorithms to create actionable insights, trigger automation, or alert users about significant events. User interact with or monitor IoT devices primarily through graphic users interfaces, mobile apps, dashboards, or web portals. Here we can observe the architecture overview of IoT based. Here application layers entered into the industrial control, urban management, power monitoring, green agriculture. Here some support platforms on the cloud. Network layer. Network layer can be seen like in these consist of Bluetooth, LoRa, 5G, small BS, Marco BS, IoT gateway, Wi-Fi app. Here some precipitation layers, sensor, surveillance camera, traffic lights, robot, laptop, tablets, phone, etc. Challenges in IoT. Security. IoT devices are frequently targets for cyber attacks due to their network connectivity and often weak security features, making robots protection a top productivity. Primarily massive data collected to IoT systems creates serious concepts around user privacy and unauthorized data access. Interoperability. Devices from different manufacturers must communicate seamlessly, but lack of standardization can cause comfortability issues and fragmentation. Scalability. Managing, updating, and tracking the rapidly growing number of devices in a large scale IoT development is increasing complex. Sensitivity. Reliable and ubiquitous network access is critical for IoT but often difficult to guarantee it in remote or infrastructure limited areas. Cost. The experience involved in designing, developing, and maintaining IoT networks can be high efficiently for smaller organizations. Solutions related to issues faced on IoT. Implementation, robot security protocols, such as encryption and strong authorization mechanism to safeguard devices data and prevent unauthorized access. Updating software and firmware regularly to fix vulnerabilities and ensure devices are protected against involving threats. Use zero trust segmentation and network policies to limit access between devices, contain threats, and minimize attack surfaces. Deploy advanced threat detection technologies, including AI and machine learning systems, to monitor networks for suspicions, behavior, and automate responses. Standardized devices interoperability through accepted communication protocols and well-defined APLs addressing accountability issues between devices. Assign unique cryptographically based identities to devices to track and unauthorized each unit throughout its lifestyles. Embedded systems. An embedded system is a specified computing system designed to perform dedicated tasks introduced an imperative components and organized devices with a large devices or applications. It typically consists of microcontroller or microprocessor, memory components, RAM, ROM, or flash, and output interfaces are interfacing with sensors, calculators, or user controllers. Embedded systems may include supporting software such as real-time operating system RTOs and application programs, enabling them to execute instructions and react to environmental changes. These systems are optimized for efficiency, reliability, and minimal size, and widely used in products like smartphones, household applications, medical devices, industrial machines, vehicles, and automation systems. Unlike general purpose registers or computers, embedded systems focus on performing specific operations, often with real-time constructions, low-power constructions, and cost-effective hardware tailored for their target tasks. Here some on project requirements. Microcontroller. Arduino Uno modules implemented garden light control, temperature regulation, and serial tank management. Display the shields, CLCD, and Ethernet shield. Simulation tools used to develop and test each prototype before physical execution. Here some see on concepts of simulation tools for project implementation. Arduino IDE platform for writing code and compiling it into HEX files for development. PSimLab virtual environment for simulating hardware and executing the compiled files. Null emulator. Blink IoT app helping control systems like temperature and tank management remotely. What are here some implementations on the IoT project? A folder is created in the name of project, including files like home automation, blink controlled LDR, CPP, IDL, serial tank, CPP, serial tank, H temperature system, CPP temperature system, H main, H. After coding in these files in Arduino IDE, export combined binary file of the INO file. In PSimLab, arrange parts like LED, LCR, LCD, LDR, temperature systems, Ethernet. Load a X file for Arduino UNO board in PSimLab to view output. Use Blink app in mobile to visualize and control the systems. Arduino UNO. Here we can observe the picture on Arduino UNO. The Arduino UNO is a widely used microcontroller board based on the 80 mega 3208P chip, which features 32 KB of flash memory, 2 KB of SRM, and 1 KB of EEPRAM for program and data storage. It operates at a clock speed of 60 MHz and uses a 5V operating voltage. The board includes 14 digital input-output pins, for which 6 can be used as PWM outputs and 6 analog input pins labeled A0 through A5. Communication interfaces supported by the Arduino UNO include UART for serial communication, SPL, and 12C, allowing it to connect with a wide range of peripherals and sensors. The board is equipped with a USB port for programming and serial communication, and a power jack for external power sources, an ICSP header for in-circuit programming, and a reset button for restarting the board. Its compact size, approximately 68.6 mm and into 53.4 mm, and user-friendly design make it highly suitable for beginners and professionals building embedded systems, automation projects, and IoT applications. The onboard LED connected to digital pin 30 is commonly used for testing and debugging purposes. The Arduino UNO is a cost-effective and reliable platform supported by a vast community and extensive libraries, making it an idea choose for rapid prototyping and educational purposes. Arduino IDE software. Arduino IDE Integrated Development Environment is a software platform used to write, compile, and upload code to Arduino boards. It provides a simple interface for coding in a language similar to C++ designed for Arduino hardware interaction. Features include cross-platform support, Windows, MOSIX, Unix built-in performances. Feature included cross-platform. The interface of Arduino UNO code editor toolbar for variety upload, new open save file, serial monitor, message area for compile, upload status, text control, and board platform sections. Here we can PSimLab Programmable IC Simulator Laboratory is a real-time emulator for development boards that supports microcontrollers for various simulators like PSimVR using QM and GPM. It integrates with development tools such as MPLabX, Arduino IDE, and VS Code, which platform for the programming, debugging, and uploading code, but does not provide its own source and editor code. PSimLab simulates real hardware boards and allows connection of multiple devices called spare parts like LEDs, push buttons, Enter Shield W50, and color graphic displays such as LEDs at the other end of boards called spare boards like LEDs, push buttons, Enter Shield. It aims to simulate a real hardware behavior, closely enhancing debugging and testing flexibility, including supporting of microcontroller like PSIM16F628 and Arduino UNO with ATM Mega 328P. Here we can observe Blink. The Blink app is a part of comprehensive low-code IoT platform trusted by over 1 million developers worldwide. It enables users to build and customize feature-rich IoT mobile apps without writing code. Blink simplifies to an entire IoT processes, including activate Wi-Fi, providing remote controlled sensors. Some applications like OTM firmware updates and secure cloud connectivity. It supports over 400 hardware boards such as ESP32, Arduino, Responsibility PA, and various. Blink Apps, a drag and drop mobile app builder for iOS and Arduino to monitor, manage, and control IoT devices remotely. Blink Console, a wide portal for managing devices, users, organizing OTA updates, and business functions. Blink Cloud, secure cloud infrastructure for hosting, scaling, and monitoring IoT solutions with real-time data processing, API connectivity. Temperature control system. Here we can flowchart of temperature control system. Blink IoT app to Arduino UNO. Here it can approach a CLCD to water tank consisting of heater resistor, LM35 temperature sensor, and cooler, resembling a home temperature controlling system. Reads the temperature and displays it on CLCD. Control heater and cooler on off through Blink IoT mobile. Here we can garden light control system. Earlier sensor is used to light depends on resistance charges with insist of light. Sensor detects the changes in resistance to control garden it. Water tank control system reads volume of water in a tank through serial communication and displays in LEDs of light. Sensor detects changes in resistance to control garden. So as we have already seen in presentation part from my now we are here to have done through this internship training applications using some kind of techniques like blink code and some Arduino. We can know about CUP, so as this is my main file home automation, billing control, and more, I have integrated all my different files into one file. As you can see the earlier the serial tank and temperature control systems and the main file where I have installed, or I can say where I have set the main pin as shown in here. So now let's move to our file, the main file. Here the very first part of the code is unauthorized part where I am configuring my configuration. So now we have moving forwarded. Here I have included some header files content in the of SPL Blink system, and so as on the going further the code is already explained through the presentation time, as we have already seen on the further, as we have already seen video, and I don't think I should have to explain the code again. So the code explanation portion is done in the of the internship can be monitored done be here some. Let's to move quickly on the simulation part, and I showed, so we have exactly the things are already working. Let me just open my PXM lab quickly, and this is my PXM lab, and I am using a boat, or you can know I have load my X files. I already did previously, so I just reload the last file to show you parts. I will have to spare parts. I have roughly arranged through parts already. So now just let's start the simulation. So first we will look into our garden light system, which we have used some components like LDR and LED, like you guys see. If I control through the LDR slider, the light sensitivity of the LED and brightness changes according through the resistance, which we have learned through the internship training period. So this is how the light system works. On moving to our second objects, we have to see our here to have, like you can see, like a blink application which I am using. I am smartphone. I have made couple of buttons and couple of ways on my home automation tab. So if I click on the cooler, you can see the cooler turns and the temperature decreases. If I click on the heater, the temperature increases as we turn on the heater. I have given some conditions for the temperature to like this notification. We can see temperature is about 35 degrees turning off the heater. So the heater automatically turns on and but reduces the temperature. We can use cooler. So you can see in temperature sensor weightage, you can see the temperature quickly reduces to 27.34 degrees. So this is my serial remote tank. So I have made separate tab 2 for it, and I have included two values, that is inlet and outlet value. So if I turn on the inlet value, the water level fills up. As you can see, it fills totally to 3000 capacity. So we can see on the LCD also the cooler and the volume is equal to 3000 and inlet is off. Coming to, we can see on the notification to tank full of 3000 to 4000 liters. We turn on the outlet of the blink of the card. So the system can be on the equal to turns, and it's automatically converts into the automations of the, it slowly gradually increase to the automations of the system. The system can be, so let's see the how to equal to 2000. The volume automatically turns on the auto outlet value stops the equal to automatically stops turns on the outlet value stops. This is turn of the how the serial tank works. Serial tank works how automation project to successfully garden into lights, and water tanking regulates motor into a single control RD platform interaction. So we can conclude that this project reflects how IoT, including comfort, efficiency. So we before conclude that the LEMS and wonderful internship, this experience was being understand embedded system. We are truly grateful this make an opportunity. Thank you.